Hi guys, I hope this video is helpful for your assignment too. Now we download the Excel sheet I shared on the course site, as you can see here. Then we open it. You can see the data I provide here. It basically have two parts. The first part is the effluent, the concentration of the calcium in the effluent as shown here. The second part is the void fraction data. How to determine the void fraction alpha is shown here. It's very simple. We already know the added water here, and also we know the total volume of the benzene we use here. So you can quickly calculate the alpha. Once the alpha is calculated, you can use alpha to calculate the one bed volume. Use the equation I showed to you in our lecture. So for the second part, the group of data, as you can see, we do the test for 142 minutes, and at each minute we collect one sample and analyze the concentration of the calcium by our AAS facility. And the next thing you need to do is, first we need to choose all the data and draw the curve like what I did here. Okay, so the next thing is, as you can see in the Excel function insert, we choose here the chart function. Click it, choose the second one, this one, and then we got the figure, the curve. You can either put a title or do not write the title. And here there's a plus function. When you click it, we can add the X titles for our curve. For the X-axis is the time, right? For the Y-axis is the concentration of the calcium in the effluent water. So you added those two blank area here. The next thing you need to do is, if there's no printer at home, you cannot use a ruler and a printed curve to find the equilibrium time. I would introduce you another way, is choose insert here, the shape function. We use the straight line. We draw a straight line to represent the ruler, and then we just keep moving this vertical straight line left, right, until we can make sure that the area here, the A1, as I showed in your lecture, equals A2, the area here. So the intersection here, this intersection is the time TE, or the equilibrium time. So in my case, as you can see, it's around 110 minutes. So our TE is 110 minutes. So the next thing is very simple. You just use the concentration difference. You need to calculate this rectangular area. Use the concentration difference times the TE times the flow rate Q, 10 gallons per minute. You can calculate how many milligrams of calcium is absorbed by the resins. The next thing you need to do is just use the value you calculate divided by the mass of the resins, you can get Q. And here, for the second curve, I ask you to use number of byte volume to replace the time t. So for the number of byte volume, you just need to transfer the time here in this column to number of byte volume. That's it. Thank you.